Hello and welcome to Algebra Unit 3, Concept 1, Lesson 2. So our objective today, remember that you should be filling out your notes as we go, is that you're going to rewrite expressions containing rational and irrational numbers. So today we're just rewriting these expressions. So let's look at these. What can I do with an expression? So let's first talk about prime factorization. Hopefully you remember doing prime factorization. Usually we do it as a tree. So to do prime factorization, all I'm going to do is I'm going to take the number and divide it into its factors. So what two numbers can I multiply together to get 100? Well, I can multiply 10 times 10. Okay, well that's easy enough, but those are not prime numbers. Remember, prime numbers have no factors other than one of themselves. So 10 can be broken down into 5 times 2. And this 10 can be broken down into 5 times 2. So the square root of 100 could also be written as the square root of 5 times 5 times 2 times 2. Well, if I'm taking the square root of 5 times 5, it's just going to be 5. Take the square root of 2 times 2, it's going to be 2. So I end up with a 10. Now that's sort of easy. We knew that the square root of 100 equals 10, right? What if we have a number like this, 2304? So I'm going to look at this and I can go, okay, well, it should definitely divide by 4. So I can put 4 over here. And then I'm going to just go ahead and figure out what times 4 gives me 2304. So 2304 divided by 4. So my other number here is a 576. Well, 4 breaks down to 2 and 2, so I'm going to leave those over here. Those are prime numbers. So I'm just going to circle them so I know that I'm done with them. So 576, well, I can see that it definitely breaks down into 2 times something, right? 2 times 288. Okay, so I see it's still an even number, so I'm just going to divide by 2 again. So that gives me 2 times 144. That 2 stays there. Well, 144 I know is 12 times 12. And each 12 can break down into 3 times 4. 3 times 4. 3 is prime, 4 is not. That becomes a 2, and a 2, a 2, and a 2. So I have 1, 2, 3, 4, 5, 6, 7, 8 2s. And then I have 2 3s. So this is the same thing as the square root of 2 to the 8th power, because I have 8 2s, times 3 squared. Okay, well, 2 to the 8th power. The square root of 2 to the 8th power is just to be 2 to the 4th power. Square root of 3 squared is just going to be 3. 2 to the 4th power is 2, 4, 8, 16 times 3, which is 48. So that's how you use it to solve some of those larger numbers. Let's look at our prime factorization. So let's try these ones. If I want to do a prime factorization of 176, I like starting with 2. So that's 2 times 88. Well, 88 is 2 times 44, which is 2 times 22, which is 2 times 11. So I have 1, 2, 3, 4 2s, and an 11. So this is the square root of 2 to the 4th times 11. Well, 2 to the 4th, the square root of that's just going to be 2 squared. But what about 11? Well, I just leave that as the square root of 11. Well, I'm not going to leave this as 2 squared. 2 squared is 4. So this is just 4 times the square root of 11 is another way to write this. Now let's try it with 200. I know I can break it down into 2 times 100. 100 is 10 times 10, and each 10 is a 2 times 5, 2 times 5. So I have the square root of 2 to the third power times 5 squared. Well, I can bring the 5 squared, just be able to take the square root of 5 squared just because 5. And then I can also bring out 2 of the 2's. And I'm left with 1 2 there. So I have 5 times 2, which is 10, times the square root of 2. All I did, the square root of 2 to the third power, I can bring out 2 of them. This is 2. And then I have 1 left over. Let's look at something else. Can I multiply these? Well, yeah, I can multiply these. If I've got 2 numbers that are both in radicals, I'm just going to multiply them because the square root of 250. But the square root of 250 can also be written as the square root of 25 times 10. 25 has a perfect square. So I'm just going to write that as 5, and then I can bring my square root of 10. Let's go over to the next one. So 5 times square root of 10 is an easy way to write that one. 10 doesn't have a perfect square root. We leave it alone. I've got 4 times the square root of 12. Well, I'm just going to write that as 4 times the square root of 12. 12 can actually be broken up, though. So the square root of 12 can be broken up into the square root of 4 times the square root of 3. Well, the square root of 4 is 2. So now I can multiply 4 times 2, which gives me 8. And then this one I have to leave alone. It's still the square root of 3. So here I have 8 times the square root of 3. One more. I have the square root of 10 times the square root of 30. Okay, so the square root of 10 times 30. So that's the square root of 300. Which is the same thing as the square root of 100 times 3. And we all know the square root of 100 and the square root of 3. Square root of 100 is 10, so I have 10 times the square root of 3. These are just different ways of rewriting these. Let's try one more different way to look at these. So, here, notice I have a number on the outside of my radical, and I have a number on the inside of my radical. So, I'm going to multiply the numbers on the outside of the radical with each other. So, I have 5 times 10 times the square root of 2 times 5. 5 times 10 gives me 50. 2 times 5 gives me 10. I can't rewrite that, so that's it. It's just 50 times the square root of 10. Let's go to this next one. Again, I'm multiplying the outside numbers. 4 times 8 is 32. 3 times 12 is 36. Wait, what's the square root of 36 again? It's just 6. So I have 32 times 6, which gives me 192 is my final answer there. Okay, good luck with your problems. I will see you all in class.